Hello dear listeners, my name is Max. I'm technical specialist in the CSoft group of companies. In this video we'll learn what are the ways to check the mesh model for incorrect elements, as well as ways to correct errors. First we go to the geometry model and import our step file. The Salome generator asks us if we want to convert the units of measurement of the model into meters. We answer no, we will continue to work in millimeters. Next, we have a new question. Do we want to create a partition? This time we will click no and discuss this operation in more detail. When objects are created in a CAD model, then at the point of contact of parts, for example a casing and a mold, there are two touching faces belonging to the casing and the mold, respectively. This is not suitable for PoligonSoft because we need to count heat transfer on the contact face of different objects, so the objects should have one common contact face. This operation in the Salome model is called partition. Let's do the partition manually. For this, we select the objects that we want to divide. Select all for objects. We go to the Operations tab and click Partition. We don't change anything and click Apply and Close. A new object named Partition 1 appears, which we now need to explode into subshapes type, Solid. Now, for example, we have a single coincident face between the casing bowl and casing. Next, we should check the model for possible errors using the Check Shape tool. We click on the check mark the Check Also Geometry again. We receive a message. This shape seems to be valid. It is a good practice to rename objects for ease of selection: mold, shell, casing bowl, and casting. Next, we need to go to the mesh model. The algorithm for creating a mesh is the conditions for creating a mesh on the edges. 1D mesh. Then a mesh is created on surfaces. 2D mesh, and then a volumetric 3D mesh is built. If you need to understand what sizes of elements you need to set for objects, then you can look in the geometry model at the bounding box tool, which gives information about the overall dimensions of all models and individual parts. First, we create a 2D mesh for the common object, partition 1. The settings are set as usual. The arithmetic dimensions that the program sets are based on the largest and smallest faces. That is, the program finds these faces and sets the dimensions based on them. Let the maximum size be 30 mm and the minimum size is 1 mm. Next, we create submeshes for casing and casing bowl, as they are thin elements which need to be improved. For casing, the maximum size is 2 mm. The minimum size is 0.5 mm. The minimum dimensions should be set with the same values, since it may be difficult to create a mesh on the touching faces of the parts at different minimum values. If the bodies are not in contact, then this moment is unimportant. We will try to calculate the submesh for casing. The program generates a report with a single error. We need to look at this element and try to fix it. We click at the button Show Subshape. If you can't see the incorrect element, then hide the mesh and click on the button Fit All. The program displays an incorrect element to the screen, and then you can display the geometry of the casing. You can see that the error occurs because of the bulging face. We can delete our mesh since we will be changing the geometry, and delete the object partition 1. There are several options for correcting the error. The first option is to fix the model in the CAD system. The second option is to check the tolerance of the geometry, since each CAD system has its own tolerances with which surfaces are constructed. These tolerances are stored in a file that we import into the Salome model. The tolerances can be viewed through the Tolerance tool in the Inspection tab. There are three types of tolerances: of vertices, edges, faces. The maximum tolerance values for vertices and edges are taken from the imported file, and the maximum value for the faces turn out to be equal to the minimum value set by the default program. We assume that such a mismatch of tolerances for the faces may be the cause of the problem. This number is very small, so it is sometimes useful to change the tolerance for the faces in the tool Limit Tolerance. There is a third option. It is to change many parameters using the tool shape processing in the tab Repair. So, for example, the fixed face size parameter sets the size of the face and will remove those faces that are smaller than this size and try to sew up the resulting holes. We will try to leave the default values of all parameters and treat our casting. Click the button Apply and Close. The message that appears tells us that one face has been removed. We click OK. A new corrected object appears in the tree Process Shape 1. Let's take a look at the resulting geometry. The face was successfully deleted. Now we need to create a partition of objects with the corrected element. The new object partition consists only of references of the objects from which this partition was made. Now we need to explode it into bodies using the tool Explode. And don't forget to rename the bodies for more information. We go back to the mesh model and try to again to create a 2D mesh of the casting and the entire model. The mesh for casting with the same parameters turned out without error. Now we create a mesh for the bowl casting. There the maximum size of element is 5 mm and the minimum size is 0.5 mm. We remember that we need to set the minimum size the same for meshes touching bodies. A warning appears that if we have several submeshes, we should set the order of calculations of these submeshes, because we need to first create a submesh with smallest element size. This is done because the constructed mesh adjusts to the previously created mesh. We can also rename submeshes. We calculate the mesh for the bowl casting. It turns out without errors. Now we can calculate a 2D mesh for the entire model. It also turned out without mistakes. Now we will check the quality of the elements through the tool 2D Mesh Quality. The report is issued where minimum angle, aspect ratio, and length 2D were checked. 6 is Jacobian number. There are many criteria by which the program filters out the elements. In total, there are 6 elements with a minimum angle and ratio, as well as 56 elements with an edge length less than 0.25 mm. If your length 2D is not 0.25 mm, then set this value. Our minimum size is 0.5 mm, so we usually put it 2 times smaller. We click the button Correct and get an improved mesh. And finally we can create a 3D mesh. It also turned out without mistakes. This is where our video ends. I hope you enjoyed this video. Leave your comments on which video you would like to see in the next video. Bye everyone.